So that's typically what you're going to see here. It's a little annoying that you can't see farther, but if anyone's ever actually looked at long-term weather forecasts, you might as well just dream about the weather and you'll probably be as accurate. So let's start with why we're not going to have the fly-in tomorrow. So this is the weather prediction for tomorrow, I guess. So what we're showing here, so remember this is altitude, so this is in feet and this is in meters. So Woodside launch is somewhere around 700 meters, so somewhere around here. And tomorrow morning at 9 in the morning at around 700 meters, we have, so these things that look like arrows without points on them.
They're eighth notes.
Sorry?
Eighth notes.
Eighth.
Toothbrushes.
That's toothbrushes, eighth notes, yeah. Fair enough. They're supposed to be arrows. So you imagine that there is, so I'll take this arrow here. So the tail of it is sort of downward. So this is supposed to represent the compass rose. So this arrow is, this one guy here is pointing approximately to the northeast. So the wind is coming from the south-southwest. And then the number of barbs on this arrow represent the speed of the wind. And so here it says the wind barbs are in kilometers an hour. To read wind barbs, these are typically used in weather plots, so you just have to learn this. The short barbs correspond to 5 kilometers an hour. On most other wind grams or things like this, it'll usually be in knots. So keep that in mind if you're looking, for example, at TJ's wind grams. They're in knots. So we use kilometers an hour because I don't think in knots. I don't know. Good reason as any. So the short barbs, so there's a tiny little one here, that's 5 kilometers an hour, and then the long ones are 10. If you see a triangle, it's not flyable. That means 50 or something?
50.
It's some crazy amount. So for example, at 9 a.m. tomorrow at around launch height, we're expecting something like 35 kilometers an hour of wind. So it's not going to be flyable. It's not that 35 kilometers an hour wind wouldn't be flyable on the coast, but in the mountains here, it's not flyable. Plus, the actual wind speed you would get on launch is likely to be much higher. First of all, because it's an unstable day, there's cloud and rain, so there's going to be gusting and all sorts of craziness. And rain also, yeah, so it's not going to be flyable for that reason too. But wind, rain, clouds, it's not a good thing. So up on the top, we typically show the ones you want to pay attention to are rain. So if there's no rain, it won't show up. That's kind of a nice thing. Rain prediction is actually kind of hard to do in weather models, so don't really trust those sort of things. It may be that it says there's no rain and there's a little rain, or it says there's a lot of rain and the rain was like on the other side of the valley. It's remarkably hard to predict. Cloud is maybe a little bit easier, but again, this is a single point in the atmosphere. So just looking at this won't really tell you the probability of rain, for example. Just because it says it's going to rain on Woodside between 9 and 11 in the morning really doesn't mean anything. It's not that detailed a model. It will have predicted rain there, but that could as well be on Bridal Falls, or it could be over Agassiz. So you have to get a little bit more information than just a single point through the atmosphere. For example, this could be, so right now we don't actually know, is this what's going to happen for the entire valley? Yes, you can pretty much guess. It's not going to be 35 kilometers an hour at Woodside and then like 0 at Bridal, but in principle, if you want to look sort of at the whole area. So a single slice through the atmosphere, what's shown on a windgram, is not always enough to decide whether it's worth going out to fly. So there's an entire section, whole other section of this that shows more than just the single slices. But you can also just, if you're lazy, you can click on Bridal Falls on the left-hand side, and that'll show you another place, which is admittedly pretty close by. It's on the other side of the valley. It pretty much shows the same thing, so then you might as well give up. But we're not going to find it being flyable tomorrow, no matter how much we click. That is if you decide to go beyond donating, you can order good weather for a bigger donation. You can create every day. So there are a bunch of places here. Unfortunately, it's a little bit cryptic. So, for example, you might not know where Pattison or Sumas or Benny or Hope or Golden Years, you probably know approximately where it is. So that itself is a little bit cryptic. If you're just on this page, you can click here on the windgram selector, it gives you a little bit of sense of where the wind grams actually are.
Oh, nice.
So there's also this off of the map
Never
page.
seen that.
So
It's new.
It's kind of
A few months.
So you can sort of zoom in, I don't know, choose your local spot. And if you click on one of these things, you can figure out where they are. So for example, that brings you to Woodside. It's useful to know what these are, especially if you're looking in an area you haven't been. So you want to travel to the interior, there are a bunch of sites whose names you've never heard of. It's good to kind of look here. And plus some of these sites are here just for our information, because maybe I want to know what it's doing up here. No one flies here. Maybe.
Wow.
But you might want to know what it's doing up in Golden Years. And if you have a site that you fly that isn't on here, or a site you want to know about, you can ask me to add it. Just tell me where it is, give me the name. Or, I think on this one, for example, let's say we wanted to know what it was doing in Maple Ridge. If you go there and you press and hold the left button for a while, and give it a second or two. This is not the most powerful machine I'm running because of the money. And this will generate you a wingram for
Pretty
Maple
cool.
Ridge.
That's awesome. Whoa!
So to donate, there's one right here.
I'm canceling my XC guys.
The problem is that there is a limitation. It will only work within about 100 kilometers of some other spot. So if you want to look in the middle of Canada where no one's ever flown before, you'll click there and it'll say no such data, contact Andrew if you want a site here. And so just send me an email, I'll have it up by the next day unless I'm on vacation or sick or something like that.
What do you need, like a GPS coordinate? Or
Yep, so I prefer GPS coordinates in decimal and decimal degrees, so minus 42 point blah 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 blah, 1, 2, 3, 4, 5, 6, 7. You can get that off of Google Maps, so yeah, there for example. So I do hope to have the entire domain available soon, but that's been since September 2018, so soon is a relative term here. It turned out it's really hard to store all the data. So,
What would it take to add the Sunshine Coast? Could you like this one?
easy.
Here, this is for next year. Here.
Here, give it to me. Okay, but yeah, seriously, if you have sites in the Sunshine Coast, just tell me where they are. Okay,
Lots of it, tons of it.
Just send me coordinates,
Yeah,
and I will
okay.
add a Sunshine Coast section.
And it'll be fairly accurate. Like,
It'll be very accurate. So, but right now, for example, you can't get dynamic wingram.
So that's seashell they just clicked on.
Yeah. So,
Oh, really?
because it's close by to other sites, you should be.
oh, I gotta go.
That looks wonderful.
For a speedway, yeah.
They're really small
So-
speedway.
I only look at the little icons of the gliders.
Yeah, so let's
That's
go
the only
back
thing I
to a
look
wingram and talk sorry?
So Miguel, what do the little tails mean?
Yeah, so it would have been unflyable.
You want to
I think he knows that. Thank you. So, okay. Some of the other things on here, these little half moon shapes here are actually half moons. They're supposed to represent, that's why we use them as an icon as opposed to a hang glider, because it was an available icon in this weird programming language. So anyway, it's supposed to represent a paraglider. And it represents the height that you can expect to thermal to on average. Sometimes it's not that accurate. So for example, you'll see this paraglider sort of hopping around, but I mean, unless you have experience with the site you fly at, I wouldn't necessarily trust this too much. It's usually a little bit conservative. So paragliders don't fly the average air. I don't know about hang gliders, but we fly the best air. So typically when you're flying, the height you will get to is not determined by the average thermal, because you're going to go and find the strongest ripping thermal you can get and climb to the top of it. So this is an average thing, and it'll be different depending on terrain. For example, you'll go tuck yourself into some, hugely sunny, sun-facing ridge on a mountain that goes up to a huge peak, and it'll go up way higher than these things.
So what indicator do you use to determine toggle width?
So I use this, and then I add a little bit.
What about for like a crappy average pilot like yourself?
Me too.
Andrew, can't you use the unstable air, like orange, isn't
Yeah.
that still rising, like basically all the way?
Yeah, so let me talk through that a little bit. So if you scroll down a little bit more, so there are colors in the background here, and what they represent, so the thing that determines whether air moves up or down is whether, as that parcel of air releases from the ground, whether it's warmer than its surroundings or not. So for example, if the surrounding air gets very cold very quickly with altitude, then that packet of warm air from the ground that's been sitting in your field of wheat or whatever will rise very quickly, and nothing will stop it because it's so cold outside. As the air rises, it cools because it expands. But eventually it cools off enough that it's at the same temperature as the surrounding, and it stops going up. And that's going to be your top of lift. So what we and the way to sort of look at that, so some people will look at these QT diagrams, which are complicated. We try and represent that here, first of all, by calculating where this guy is for you. Again, it's a little bit of a rough calculation. But what we present is this sort of color scale on the background. And what that's showing is the change in temperature per 1,000 feet? Per thousand feet. Yeah, the lapse rate. It's in weird units because it's degrees Celsius per 1,000 feet. You would think that it would be Fahrenheit per feet or Celsius per meter, but it isn't. That's just the world.
So I got a question. Is it possible to change either the pink or the bright blue on the sides? Because for me, that's... I don't know how you guys see it, but for me, it kind of is a little intense.
Colorblind side, yeah.
Might be the
I mean, yes.
It's like, it could just be grey on the side, and then... I don't know.
I can probably
just a
change
comment.
so if you could send me an email, so there's a contact
right
list
near the
somewhere.
donate.
Yeah, so there's
Can you arrange custom color? Is there a custom color tab?
if you click here, it'll send me an email. So send me an email and say that because
We'll take you to the donate screen where you can send an email.
yeah, I'd be happy to change that if it's hard to see. The colors here, strangely enough, have been evolved over the course of probably over a decade. It started out, TJ, who was a pilot in the northwest of the US, so in Washington, some of you may have known him. He put this windgram visualization together to begin with. He was the first guy who sort of came up with this. And it turns out, once you get used to it, it's an incredible way to look at the weather. So it's due to this was not invented by me and Peter. Peter and I added some of this stuff and tweaked it a lot, but the actual visualization and the color scheme and all that comes from TJ. And he spent a lot of time trying different colors. And it looks kind of cheesy in sort of 1990s internet, but it turns out it carries a lot of information. It's sort of when you glance at it. Yeah, there's a... His old site is archived, so you can see what 1990s internet looks like. Okay. So what we show on the background here, for example, is it's labeled down here. So red means that the lapse rate is more than 3 degrees per 1,000 feet. So roughly, if the lapse rate is 2 degrees per 1,000 feet, the air is stable. That means basically nothing's going to be moving up or down. It's not exactly that. It's a reasonable estimate. If it's more than -3 degrees, you're going to have thunderstorms and craziness. Like air is just spontaneously rising from the ground and shooting up there and doing all sorts of craziness. So when you see people calculate a local lapse rate, for example, you look at Jim's site of the day.
This is the same thing year round.
It's always -3.
Yeah.
It never changes. It never changes.
I think, yeah, it's always good at 5EC. But occasionally he'll update things, and he'll usually quote a lapse rate. Now, what he does to calculate that is choose some point in the atmosphere and the ground and calculate the temperature difference and whatever. He's trying to capture the general instability of the day. If the day is, okay, so for example, let's go to nighttime. So this portion is night, this is the evening. What it's showing is gray. That means the temperature is actually increasing as we increase altitude. So for example, some days you'll go to some flying site, you'll be in the valley, it'll be chilly, you'll go up to the flying site and it'll be warm. That's usually not a good sign. That means that there's no impetus for the air on the ground, even if it's being heated by a little bit by the sun, for it to rise. It doesn't want to, it's warmer up top. So And that happens every night. So every night you will typically get, it's because the ground cools off by radiation from the ground, and so it ends up cold on the ground and warm up high. Yeah. You should ask me about questions if you want more details about the physics stuff. Preferably before I finish my second beer.
You're doing fine.
But I am always happy to talk about weather physics stuff. But I find that maybe it's not useful. So anyway, so for example, the red means that pretty much the air is going to be rising at that altitude. And what this is saying usually, so where are we looking at? We're looking at something at high altitude. This is golden ears. It doesn't matter. So it starts at 700 meters. Up there, pretty much at this, even early in the morning, it's going to be unstable. It's a little bit odd. The sun hasn't really risen yet. Or actually it does. It rises at 6 something. It wakes me up. But sometime pretty early in the morning, you'd find if you were at high enough altitude, you'd be able to launch pretty early. It's, this is a little bit crazy because it would start raining just about then. This is probably because it's just, so it's the reason it rains, or the reason you get puffy cloud formation. The ground heats, the thermals come up, they rise high enough that they condense, that all the moisture from the ground condenses, it creates a cloud, and then eventually all that water is going to come down. But that's not really why it rains. It rains because weather hates current. So what you want to look at, so this guy here, for example, this is just a bad day. Can we go back to last Saturday? Yep. Last Saturday was a great day in Pemberton. So I'm going to use that as an example, because first of all, I flew there so I can compare with what it was. Hopefully some other people got out there too, because it was good. So if you go to single day, so you can go to duration 1 day here, and then it changes to this thing, and we can go back to April 20th, Saturday. And let's do, so 1 day HRDPS. So this is, and let's go to Pemberton. So see this guy. And then Mackenzie launch.
So these are all forecasts in the past.
This is in the past.
How do you forecast in the past? Like, is this actual data for what happened?
No. This is the forecast that was done Saturday morning. So this is what you would have seen if you woke up and turned on the RASP.
And on that note, is there any way for us to see, for example, it's supposed to snow on the mountain tomorrow? Is there any way to see how much actually fell?
Yes, but not here.
Go up and down and measure it.
Yeah, so for amount of snow in mountains, I actually don't know. If you're interested in sort of wintry snow type stuff, there's okay, send me an email. I'll send you the best weather site ever for winter forecasting. It's Avalanche EC or something.
Oh, yeah.
They have an incredible blog, and you'll learn so much about how weather works by reading these people. Like, they are obsessed with it, and they put up plots and interesting things and discussions. And it's even worth looking at during the summer because they continue to do it anyway, even though it's not really snowing anywhere. I guess you got to work year round, but they have some interesting things to say about weather and well worth
So
looking
those
at.
would be all observational, and that's great. But for areas that have no people actually looking at it, right? Are there any digital systems out there to say, okay, at the moment of this forecast, here was the current conditions, and we think this much?
You can look at the Cypress webcam that shows actual snow on the snow scale.
Yeah, but there are people up there too. But that's one of the challenges of most of Canada. There is not much in terms of observation. So some of the data that comes into these weather models is kind of interesting. So how do you tell what feeds this stuff? So we have airplanes flying everywhere continuously. All of them carry instrumentation that tells you temperature is a function of altitude, temperature where they are, and maybe humidity, I'm not actually sure. That information gets fed into all these models. So the fact that we have airplanes flying everywhere is actually kind of important. A lot of the initialization data comes from satellite imagery. So they're going to look at the ground and say, look, there's snow there. Turns out the snow matters a lot because when the sun shines on it, it reflects. And it also melts and makes things wet and all sorts of things. And also the satellites tell us about where clouds are and things like that. They also send up balloons to measure pressure as a function of altitude. All these things go into these models. It would be neat if all that data was available in an easy way. But it turns out that generating visualizations of weather like this is hard in a general sense. First of all, because what a weather person might be interested in is not necessarily what we're interested in. So you have to get a weather person who really wants to communicate weather beyond all the details that they're concerned about. Anyway, that was a bit of an aside. So this is Saturday in Pemberton. So I woke up and I looked at this, and so what did I see? So first of all, I saw that the wind was light. So for example, down at around launch height, lower launch, because we can't drive to upper yet, the wind doesn't even have barbs on it, which means anywhere from 0 to 5 kilometers an hour. That's great for, at least for us paragliders, because we don't go very fast, and that means low wind-induced turbulence. It means you can go cross country without getting blown over some mountain somewhere. So that was the first thing I saw. Even up at altitude, so at way high altitude, of course, the winds are always high. So don't look up at way above where you're going to get to. In this case, it said that there were going to be puffy clouds. That's what these white things are. They're clouds, not marshmallows. It's again built into this. The thing that generates this is actually a language sort of developed toward visualizing weather stuff. So it has clouds and moons. The moon is not, it's rotated, so it looks like a paraglider. So what it was saying is that at 8 in the morning you could be at 1,000 meters. We know that is not the case. You cannot go up to Pemberton and launch at 8 in the morning and be at 1,000 meters. But so you have to do a little bit of fly the site, compare to this, and go back and forth. But what it says is the paragliders were in the clouds from 10 a.m. until around 1 p.m. Now we know there wasn't complete cloud coverage in Pemberton, so I was out there and there were little tiny sort of wispy, not really fully developed clouds. Especially in the afternoon, they kind of disappeared. So this is saying there was cloud in the morning. There's probably some leftover moisture on the ground, I don't really know. And the paragliders never go above the clouds. So that's one thing to know. If you see clouds, the paragliders are always going to be at them because it's illegal to go above them, so we don't visualize the paragliders above them, even if you could film past them.
Those ones are clearly inside the clouds.
It's all a matter of perspective.
Just the wing. Just the wings, okay.
So using this background color scheme, so let's go through that, for example. So here it says that when I go up from launch height up to around, this is somewhere, let's say 1,700 meters, the color starts to get less than 2 degrees per 1,000 feet. You can see there are labels here. So when it gets to be stable air, that means really nothing is going to rise past that. Anything up here, between say minus 1.5 and 2.5, if there's hotter air below it, chances are the air will continue to rise through it. So up here we know that the thermals, so early in the morning, this is 8 a.m. to about 1 p.m. What it's showing is that the paragliders and the thermals would get up to maybe 1,500 meters and they would just stop. Okay. There were also clouds there because there's this inverted section of air left over from the morning, from the night. And eventually, by about, so somehow there's a bug in here, and these like nighttime numbers are showing up there. You just have to ignore all the bugs and just look at the good stuff. So ignore the 6 and the 7 that should be living here. I've never noticed that before. But by about 1 p.m., top of lift was predicted to be about 1,800 meters. 2 p.m. about 2,000, and by 4 p.m. maybe 2,200. And then at 5 p.m. it all shuts down and the paraglider gets low. Even though from the background colors you wouldn't really expect that. So what actually happened was that we launched around 1 p.m., which is the typical launching time in Pemberton. Unless you get to upper launch and it's an epic day, you're typically launching around 1 p.m. We pretty much pinned out to 2,600 meters right then, maybe 2,400. So obviously the predictions were a little bit off because we were up around here. And it's a little hard to predict. This air here is this conditional, it's a little bit less than 2 degrees per 1,000 feet, but there was a lot of heating from down below. So what we do to calculate these paragliders, we take a parcel of air on the ground, and we just raise it up, cool it down, raise it up and cool it down until it eventually hits this temperature. If you increase the ground temperature by say 1 degree, this might be off the scale for all we know. So I don't show you how uncertain this prediction is. So you just have to get a feel for it. And that's what that background color tells you. So chances are you're not going to really get up to 3,000 meters on this day because this is not even conditionally unstable, but maybe you can get a little higher than that. The other thing to notice on this are these sort of black lines. These are actually telling you the temperature at that altitude. That's what these numbers are calculated off of. So for example, at 4:30 p.m. at 3,200 feet, it was going to be about 8 degrees. This is really useful if you're deciding what clothes to wear. You go look at the paraglider, and up here, the paraglider is at -2 degrees. -2 degrees and 40 kilometers an hour of wind, it's going to be really, really cold. So bring more clothes on that sort of day. So that's why we have the temperature things here. It's kind of important, you know, because you don't necessarily know. This windgram starts at 509 meters. It's not exactly a Mackenzie launch. So the other thing to know is that this weather prediction, what it does, it takes the world, which is a very detailed thing with billions of people and lots of terrain, and it breaks it up into 2.5 kilometer grid chunks. So it takes basically all of Pemberton, maybe a half a kilometer on each side, and it just treats that as one point in the model.